Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 12 from the C12 October 2020 paper. Now, this is from the old specification. Now, this 12, actually part A and B relate to things which are in P2, and part C relates to what's now in P1. So I'm going to do them separately. I'm dealing with P1 right now. So I'm just going to answer part C of this question. Part A and B will be done if I get around to do it on a separate video. Okay, so this question here, part C, is related to trig graphs. Solving trig equations is now in P2, and trig graphs is in P1. Now, figure 2 shows a sketch of the curve with the equation y equals tan x between 0 and 2 pi. And the curve with equation y equals 5 times cosine x between also 0 and 2 pi. Okay, so these are those two equations. Now, of course, this is the one which is for tan x, and this is one for cosine x. Okay, 5 cosine x, because we know that the tan x curve has these asymptotes and its range is infinite, and the cosine curve, you know, it's got this type of shape like the sine curve, and it has a maximum minimum range. In this case, that's going to be +5 and -5, because if it's just cosine x, it'll be 1 and -1. Anyway, we don't need to know that for this question, just a side point. But part C of this question states or asks us to find the number of solutions of the equation tan x equals 5 cosine x. They've told us that these curves meet at A and B. All right, now what we have to understand here is that the tan curve repeats itself every 180 degrees, every pi degrees, and up to here is pi. Up to here is pi. Okay, that's pi, 180 degrees. And the cosine curve, if it's cosine 5 cosine x, as long as this is 1x here, this repeats every 2 pi. Every 360 degrees, every 2 pi, you'll get the same shape, repeating again and again. So you're going to get this same thing repeating again and again. Okay, if you were to copy and paste and stick this on the end of that, you would get, you know, until 4 pi exactly the same shape as this. It will look exactly the same as this. And then another 4 pi, it will look exactly the same as this. So how many times will there be solutions in the interval from 0 to 21 pi? Okay, so, well, first of all, we can see from 0 to 20 pi. Let's deal with that first. I've got this little sketch made here. So part 1, what we can deal with is for part 1. We know from 0 to 20 pi, okay, you're going to have how many solutions? Well, from 0 to 2 pi, there's 2 solutions. Okay, from 0 to 2 pi, there are 2 solutions. So from 0 to 20 pi, there are how many solutions? Well, 20 divided by 2 is 10. So 20 pi divided by 2 is 10. So you're going to have 10 times 2 solutions, which is 20 solutions. Okay, there's 20 solutions. However, they ask us for part 1, they want us to do from 0 to 21 pi. So I split it up to 0 to 20 pi. Then now, from 20 pi to 21 pi will be the same. It will look like this. This could be 20 pi, that could be 21 pi. That's exactly how it look further along, right? So you can see there's 2 solutions further between 20 and 21 pi. Okay, so you got 20 solutions plus 2, that's 22 solutions. Okay, explain briefly the reason for your answer in each case. So for number 1, we could say there's 22 solutions. Why? Because you can say between 0 and 2 pi, there are 2 solutions. So between 0 and 20 pi, they're going to be 10 times 2 solutions. In fact, what I wrote there is perfectly fine. That's like an explanation, right? And then between 20 and 21 pi, there's going to be 2 solutions. So therefore, you're going to have 22 solutions. So in fact, what I wrote there is perfectly fine. I didn't just write the answer down. So, I mean, what I wrote there is basically an explanation. Okay, not in a proper sentence, but that's perfectly fine. All right, that's part 1. Now, part 2, okay, it's asking us to find for tan x equals 5 cosine 2x. So tan x tan 2x, sorry. Tan of 2x equals 5 cosine 2x. So the tan of 2x equals 5 cosine of 2x. Now what's going to happen basically when you have this 2 inside the function, what happens is it basically gets stretched by a factor of a half. Okay, it gets stretched by a factor of a half. So basically, tan 2x, tan x would be here between 0 and pi. And this would be 2 pi. For tan 2x, this would be 0, and this would become pi, and this would be pi over 2. This would be pi over 4. That would be tan 2x. And same for cosine 2x, it will also be, this would be pi over 2, this would be pi. Right? So we can see between 0 and pi, there are 2 solutions. So we want from 0 to 20 pi, so that's 20 times the width. That's going to be 20 times 2 solutions, which is 40 solutions. So you're going to get 40 solutions. So showing this kind of ratio is briefly explaining, the reason for your answer in each case. That's fine. Okay, that's absolutely fine for you to just leave your answer or show you how you use the proportion. That between 0 and pi, there are 2 solutions. Between 0 and 20 pi, there's 20 times as many solutions. Okay, this time they didn't ask for the 21 pi, so it's simply as simple as that. There are 20 solutions between 0 and 20 pi because you basically now caused this to become stretched horizontally by a factor of a half. You're going to fit twice as many solutions in now, so it's going to be 40 solutions. Okay, so there's the answer to question C, part 1 and 2. I hope that was clear. Now, what I want to just do to make it even clearer is the following. I'll just make some space down here, just to illustrate what I'm trying to say from the beginning. If I take this and I just paste it down here, let's make it a bit smaller. So this is from 0 to 2 pi, right? Now, if I was to take that same shape, hold on a second. Okay, so if I was to take that same shape and add it to the end of this, okay, that's going to be like 4 pi. Okay, that's 4 pi, because this whole thing just repeats every 2 pi. This whole will just repeat every 2 pi. And if I was to take that again and, just add it to that, would be 8 pi. And then again, 12 pi. And then again, and so on. 10 pi, 12 pi. So altogether, in 20 pi, up to 20 pi, you're going to have how many of these? All right, you're going to have 10 of these. Okay, because in 2 pi, fitting into 20 pi will be 10 times. So you'll have 10 times, there's two solutions, 2 places where they intersect. So it's going to be 2 times 10, which is 20 solutions. But then you have, at the end, you have an extra pi at the end. So up to 21 pi will be up to here. Okay, so this is 20 pi, this will be 21 pi. So you'll have another 2 solutions. That's why it becomes plus 2, 22 pi. Just like a visual for you to understand, how this, because this repeats every 2 pi. All right, that's just a little visual for you to understand that. Okay, and for the second question, because you have a horizontal stretch of factor half, you're going to have twice as many solutions fit into that, because now instead of this being 2 pi, this is 1 pi. Okay, this is now 1 pi, and so in 20 pi, you're going to have 20 times 2, which is 40 solutions, and here they didn't ask for the extra 1 pi, it's up to 20 pi. So those are the reasons for those solutions. I hope that made it a bit clearer. Thank you for watching. Other questions you might want to watch from this particular paper, you'll find in the playlist over here, and I'll label in the front of the question whether it's a P1 or a P2 style question. Other questions you might want to watch from trigonometry of P1 curves, trigonometry dealing with trig curves, and will be in this playlist over here. You can subscribe to my channel by clicking on this link here. Thank you for watching. I hope you understood, and see you soon. Don't forget to click on the links in the description for further material. Thank you.